Concept of momentum. All objects have mass, and if it is in motion, it also has a velocity. The combination of this mass and velocity gives the object a dynamical property called momentum. The momentum of an object is equal to the product of its mass and velocity. That is, if the mass of an object is m and its velocity is v, then its momentum is mv. Let's understand the concept of momentum with an example. Suppose two similar trucks, one loaded and the other empty, are moving at the same speed. In this case, due to the mass of the loaded truck, its momentum is relatively high. Now, if two trucks have to be stopped at the same time, more force must be applied on the loaded truck than the empty one. Consider again that the two trucks have the same mass, but different velocities. In this case, the higher the speed of the truck, the higher its momentum. Now, if we want to stop the truck at the same time, more force must be applied to the faster truck than the slower one. So we see that the amount of force required to stop an object in a given amount of time depends not only on its initial velocity, but also on the combination of its mass and velocity, that is, its momentum. It is noticeable that the momentum of an object depends on both its mass and velocity. Mass is a scalar quantity, but velocity is a vector quantity, so momentum is also a vector quantity. It has both magnitude and direction. In the case of momentum, the direction of velocity is considered the direction of momentum. Now, if we talk about the unit and dimension of momentum, then the unit of momentum is equal to the unit of mass into the unit of velocity. We know, in the SI unit system, the unit of mass is kilogram, and the unit of velocity is meter per second. So the SI unit of momentum is kilogram meter per second. Similarly, we can write the CGS unit of momentum as gram centimeter per second. The dimension of momentum is equal to the dimension of mass into the dimension of velocity. We know the dimension of mass is m, and the dimension of velocity is LT inverse. So the dimension of momentum is mLT inverse.